Hello everyone, in this video we're going to go through the process of moving data between CAD and Google Earth. Here I have a flowchart that outlines the general process of moving data between the most commonly used CAD packages and Google Earth. So starting from the very top we have AutoCAD the base version and AutoCAD LT. Unfortunately there is no direct connection between these versions of AutoCAD and Google Earth. You would have to use plugins in order to georeference and convert your drawing to then be able to import it into Google Earth. Depending on what plugin you use, you will be able to convert your drawing either to a shapefile or a KMZ file or both. Then we have AutoCAD Map 3D. This version of AutoCAD has the capability to georeference drawings and to export out to shapefile and KMZ. Similarly, we have AutoCAD Civil 3D, which is an extension on top of the other two versions of AutoCAD. It gives you the capabilities of designing civil engineering projects. And it also has the features that are found in Map 3D embedded into it. So you can georeference your drawings and export to shapefile and KMZ. If you're using these versions of AutoCAD, you could also use plugins with them. They are simply going to make the process of moving your drawings to Google Earth a little bit faster and give you more freedom. Because when it comes to Civil 3D, for example, many of the objects that you can create in the application are called special Civil 3D objects, meaning that they are objects that only Civil 3D can read. And even if you try to export them out with the default tools for exporting to KMZ or shapefile, you are not necessarily going to be able to export them. You would have to first of all explode them, for example, that is convert them to basic geometry before you can export them out as shapefile or KMZ so that Google Earth can read them. Now, plugins are simply going to speed this process up. They're also going to convert these Civil 3D objects to basic geometry before they can export it out to Google Earth, but it all happens much faster. So if this is something that you do very often, then over the long term, it may make financial sense to invest into a plugin if it saves you hours over the course of a year. Then we have Vectorworks. Now, the latest versions of Vectorworks from version 2018 or so and above are able to georeference drawings and export out to shapefile. So you could potentially export your drawing out in this way to Google Earth, since Google Earth can open shapefiles. However, the process is not very straightforward from what I've seen, and earlier versions of Vectorworks may not be able to do this at all. So in those cases, you would have to export out your drawings to CAD, and then in CAD, you would have to georeference the drawing and then convert it to a format that Google Earth can read. So you would also have to have plugins unless you have AutoCAD Civil 3D or Map 3D. Then we have Carlson Survey, Trimble, and Bentley MicroStation. So far as I know, all of these applications have interoperability with Google Earth in that they can export out to KMZ and or shapefile. Now, with all of that covered, we can dive into the actual process of exporting out a drawing from a CAD application like Civil 3D to Google Earth. We're going to use both the native tools that are found in Civil 3D as well as a plugin. And we're going to talk about the different plugins that are available and the ones that we are using and recommend. So here we have Civil 3D loaded, and I've already opened up a drawing of one of the projects that we've been working on. The first thing to mention is that this drawing has already been georeferenced before I even created any of these drawings in it and before I imported any data. So this is the first step that you have to undertake when you're starting a new project in AutoCAD or before you start importing data in an existing AutoCAD project. Normally, we will always use a plugin to georeference our drawings because over the long term, it pays off because it's faster, but Civil 3D has the native capability to do this. So if you want to do it without any plugins, all you have to do is to go under the main Civil 3D menu, just by clicking on the Civil 3D icon in the top left corner, and then go under Drawing Utilities and choose Drawing Settings. From the Units and Zone tab is where you're going to be performing the georeferencing. The first thing to mention is that you should always use the instance of Civil 3D or AutoCAD that is using the units of measurement that your project is in. Civil 3D has an imperial instance and a metric instance. In this case, our project was in the US, so we were using the imperial units. And we can see that under drawing units, we have feet selected. Now, under the zone section is where you're going to be choosing your datum and your coordinate system. We ourselves like to use the UTM datum and projections whenever possible because they are universal and fairly self-explanatory. But if the project requires it, we are going to use a different projection. So this is something that you have to establish from the very beginning because it is absolutely crucial. If you have to convert your projections later on, it may cause many issues, so it is best if you can avoid that. I already know that this project is in UTM zone 15N. If you've noticed, all of my projects follow the same naming convention. So first of all, we have the location of the project. This one is in the US, and then it's followed by a number, which is the UTM zone, and then by a letter, which is either N or S. N stands for the Northern Hemisphere and S for the Southern Hemisphere. Google Earth can also help you to establish which UTM zone a project is in. I can open Google Earth Pro very quickly here. And to find out the UTM zone of this area, which is the area of the project, I can go under the Tools menu and then under Options. And I'm going to make sure that Universal Transverse Mercator is enabled under the Show Lat and Long section. And then I'm going to press OK. And in the bottom right corner, we're going to find a number and then next to the number, a letter. The number is the number of the UTM zone and the letter you can disregard completely. So all you have to know is which hemisphere you're in. Is it a Northern Hemisphere or a Southern Hemisphere? So if you're in the Northern Hemisphere, then the letter is N, and in the Southern Hemisphere, it will be S. Now, I know this is in the Northern Hemisphere, and just to confirm that, I can zoom out a bit. And we can see that this is well into the Northern Hemisphere. And if you don't see this grid, then you can enable it under the View menu and just toggle on the visibility of the grid or press Ctrl and L on the keyboard to turn it on. So with this information, I can go back into Civil 3D and under Categories, I'm going to expand the drop-down menu and I'm going to scroll all the way down until I find the UTM datums. Now, if the project was using metric units, I will be selecting the UTM WGS84 datum. But since this project is in the US and it's using imperial units, I want to use the UTM NAD83 datum, which is the equivalent of the WGS84, but it's simply in imperial units. So I'm going to select UTM NAD83. And now from the list of available coordinates, we can choose the coordinate system that we need that is within this datum. We know that the coordinate system we're looking for is in zone 15N. So I'm going to expand this list and we're going to look for zone 15. We can see that we have 3 of them. If the project was using US feet strictly, then this is the zone that I would choose. But in this case, we're using international feet, so I'm going to choose zone 15N in international feet. And with that being done, I'm just going to press on Apply and then OK. Now, as already mentioned in the beginning, this entire process can be performed in a couple of clicks just by using a plugin, but we're going to cover that in just a little bit. For now, I just wanted to show you how you can export a drawing just by using the native capabilities. Now, with the drawing georeferenced, all we have to do is to export it. To do that, I'm going to type the command map export, and then I'm going to press enter. Now, this pop-up window will appear. Choose a location on your hard drive where you want to export the drawing to, and then give it a file name. I'm going to call this project, and then from the list of file types, we can choose either SRE shapefile or Google KML. Both of these file formats are going to load inside of Google Earth Pro, but I prefer to use KML in most cases. So I'm going to use Google KML, and then with that done, I'm going to press OK. Another pop-up window will appear. You will be able to choose whether you want to select everything inside of the drawing for exporting, or if you want to use a manual selection. Now, if you prefer manual selection, then choose this option, and then you can click on the icon right next to manual selection, which is going to send you back to the viewport, and you're going to be able to make a selection. I'm going to make a marquee selection by left-clicking once in the bottom right corner, and then dragging out a selection, and left-clicking again in the top right corner. And now with everything highlighted, I'm going to press enter. Now we can see that 406 objects have been selected. If your objects carry additional attributes, information that you want to preserve and to embed into them so that you can have it inside of Google Earth, you can head over to the Data tab, and from here you can select attributes that you want to export. Under the Options tab is where you can make a coordinate system conversion if you need to, or you can apply a coordinate system if your drawing does not have one. In this case, we already applied one, so we don't have to do this. And with all of that done, I can press OK. And now the project has been exported. So I'm going to head over to my desktop and I'm going to find the KML file here. So I can just double click on it to load it inside of Google Earth. So this just about covers it for how to export basic drawings from Civil 3D to Google Earth using only the native tools. If you had special Civil 3D objects, such as grading objects, you will not be able to export them out to Google Earth as they are using the native tools. You would have to first of all reduce them to basic objects such as polylines by, for example, exploding them using the explode command. Now we can take a look at the different plugins that are available for the different versions of AutoCAD. So whether you're using the standard AutoCAD or AutoCAD Map 3D or Civil 3D, you can still use those plugins to speed up your workflow. Now, the first plugin that we used, and this is the one that we used for many years, longer than any other, is called Plex Earth. I suggest that you just head over to their website and check out the different features and pricing that they have. Now, in my opinion, this plugin is really good and probably the best out of all of them. So why did we ultimately switch away from it? Now, it's because they changed their pricing model and they changed the way by which payments are made. So it used to be possible to use the plugin on a monthly basis, and now it is just an annual license. Also, if you want to have a month-per-month contract with them, every time you want to use the plugin or subscribe for a month, you have to write to their support, and then they have to prepare a custom invoice for you, and then you have to pay it, and then you have to wait for them to grant you access, all of which takes quite a long time. Now, the way we work with our clients simply does not align with this process, because we may need to use the plugin on a very short notice, and we simply cannot afford to wait several days to receive access. Also, the pricing has now increased to what is, in my opinion, very expensive for what this plugin offers. And again, this is on an annual subscription, so you don't have the option to just buy it once and keep it forever. So this is ultimately what drove us away from using it, but still I recommend it highly from the perspective of the features that it has. So if this is something that you can afford and makes financial sense for you, then I suggest that you explore the offerings that they have. The second plugin that we tried is called CAD Earth, and this is their website. Now, this plugin is, out of all of the ones that we've used, probably the least developed. It's by no means bad, it's a very good plugin, but to me, when I was testing it, it felt a little bit clumsy or outdated. Maybe things have changed now, I don't know, I haven't tried it recently. It drew us because it has a very flexible pricing model. You can buy it just once and keep it forever if you want, or you can pay monthly a small sum. And all of their licenses are a floating type license, meaning that you can use this plugin on any computer unless it is being used on another computer at the very same time. But if you're using it just by yourself, you can switch devices and you don't have to worry about the plugin locking you out. This was another big problem with Plex Earth, in that if you change machine or if your machine changes some configurations, then the plugin is going to detect that something about your system has changed and is going to lock you out, and you have to write to their support to unlock it. And again, all of this may happen at some crucial time where you need the plugin. It certainly has happened to us and it was quite frustrating. But CAD Earth is a pretty good plugin and they have a free trial, so I recommend that you just download it and try it out for 30 days. And finally, we have the plugin that we are using at the moment. It's called Spatial Manager for AutoCAD. We've been using this for just about a year now. It is very similar to Plex Earth in its functionality. In some areas it is superior and in others is not. For example, one area in which this plugin is lacking is in its ability to export special Civil 3D objects, like grading objects. It simply cannot do that until you, for example, explode the object in order to reduce it to a primitive geometry. Whereas Plex Earth could export special Civil 3D objects on the fly, it did not require for you to take any additional steps. But one thing that I've noticed about this plugin is that the developer is very active. Over the course of the year, we've already received many free updates, so I have faith that sooner or later this plugin is also going to have that capability. The price of this plugin is fair in my opinion. It is much cheaper than Plex Earth, and you can also just buy it once and keep it forever, and you get an entire year of free updates and technical support, which in my experience was very good. So now we can go through a very basic demonstration of how we can use the Spatial Manager plugin to export this drawing out to Google Earth Pro. But bear in mind that the plugin has a lot more functionality than that, so feel free to explore it in your own time. When you first install Spatial Manager, you're going to get a Spatial Manager toolbar in your list of toolbars. This is going to contain shortcuts to all of the commands of this plugin. You also get a mini toolbar that has the same shortcuts. So in most cases, I just use the shortcuts from the mini toolbar. Again, the first step when you're starting any new project is to georeference the drawing. And just a quick note, I removed any of the georeferencing information from this project. So under the drawing settings, we can see that we do not have any georeferencing information assigned. So to georeference the entire project using the Spatial Manager plugin, we can click on the coordinate system command. We're going to get this coordinate systems catalog window. In the search field, we simply have to type the EPSG reference code of the coordinate system or simply its name. I know that this project is in UTM zone 15N, so I'm just going to type that in the search field. And I'm looking for the WGS84 datum, and we have it here at the bottom in feet. Now, this is not something that you have access to from the native list of coordinate systems in Civil 3D. As we already talked about, you're going to have to use the NAD 83 UTM zone 15N if you're using the native list. But the plugin allows us to find a coordinate system in the WGS84 datum in feet. So I'm just going to select that for zone UTM 15N. Once I've selected it, I'm going to click on select, and now the drawing has been georeferenced. From here, we can simply click on the export to Google Earth command. Now from this pop-up window, I'm going to just keep it to select all objects, but you can also make a manual selection through the 3 commands here. If you want to select anything in the viewport, click on the select objects shortcut, and you're going to be switched to the viewport where you can make a manual selection. You can also select objects by layer if you want to, but again, in this case, I'm going to just select all objects. And with that done, I'm going to press OK. Now you can navigate to your location on your hard drive where you want to save out the file to. I'm going to save it to my desktop, and this is the name that I'll give it. We have the option to save either as a KML or a KMZ file. In this case, it doesn't matter, so I'm just going to leave it at KML and press on save. And now the plugin is going to go through the process of exporting that, and we can see that it was exported successfully. We have 2 options here. We can open the file directly in Google Earth, or we can just open the file location. In this case, I want to open it directly in Google Earth, so I'm just going to click on Open in Google Earth. And now here we have our project overlaid inside of Google Earth Pro. Now if I zoom in to compare the file that we exported out with the plugin to the one that we exported out using just the native tools, we can see that they overlay one on top of the other just perfectly. So you can use whichever workflow you prefer. They're both going to yield the same results ultimately. It's just that with the plugin, it's a little bit faster. And with all of that complete, we are ready to wrap up this video. Thank you for watching and see you in the next sessions.